Hello, everyone. We are going to start with a very simple and brief introduction about pricing, which is an important topic in paper PM or F5. Uh, Here we follow. I mean, we know you guys all know that there are certain principles and certain ways of calculating the selling price. I mean, no, we know that there is a cost plus pricing concept. There is a markup concept. There is a margin concept. But in this particular video, we are going to deal with another type of concept which you guys have already seen in your previous economics subject, where economist says that whenever marginal revenue is equals to marginal cost, at this particular point company can maximize its profit, right? So we are actually going to apply the same concept in our performance management paper, in pricing chapter basically. So there are few steps which we will follow in arriving this in the establishment of this particular condition. There are few steps which we usually perform if we really want to identify a selling price at which company can maximize its profit. And why marginal revenue should be equals to marginal cost? Because marginal revenue represent one extra benefit from which can be generated from selling of one additional unit, right? And marginal cost represent the extra cost which company is bearing by producing one extra unit. So when suppose one additional unit require $10 to produce, $10 is the variable cost per unit of the product, right? This is the variable cost. And the marginal revenue of one particular unit, I mean, this is the marginal cost. And if marginal revenue of one particular unit is $10, then that means what? That means this is the point where company can maximize its profit. So what happen if we produce more? See, there is a logic behind this. In economics, there is a curve which is called the marginal cost curve. That is made like this. I mean, initially your variable cost decreases, but with the passage of time, as soon as your production start further increasing, your marginal cost is going to increase. And why this is so, that we will discuss in our normal regular course. Right here, this is just a short clip of how to apply this concept. So we are not going to discuss these areas that we will discuss in our regular syllabus. We are just going to apply these number crunching type, that how we are going to apply this, right? So first of all, what you have to do, you have to identify. I'm reading this part. You have to identify a selling price at which you can at which theoretically demand will be equals to zero, and the formula is P is equals to A minus BX, where P is the price at any quantity or any sales volume. A is selling price at which demand is equals to zero. B is change in selling price divided by change in sales volume. And X is the sales volume, right? So this is basically the equation which we will use in order to proceed towards in a situation where marginal revenue is equals to marginal cost, right? So examiner, first of all, you have to identify. Let me try to change in color. First of all, we have to identify this A and this B from by using the question, because A and B of each question is different, right? um, then we will plug in the same value of A and B in this equation and rewrite this equation. And when we will rewrite that equation, that rewritten form of equation will actually represent price function for our question, for our scenario, right? Then we have to convert this price equation into marginal revenue, right? We have to convert this price function into marginal revenue function, right? And how we will do that, we will discuss that in our question. And then we will calculate marginal cost, and then we will equate that, right? So let's suppose a scenario. Let's assume a question. Let's try to think a scenario where company can sell around 10,000 units if the selling price is around $50 per unit, right? And the situation says that if you increase your selling price by by $1, your sales volume is going to decrease by 500 units. This is basically the situation. For because we know that whenever we increase the selling price, if this is a normal product, sales volume is going to decrease, right? So if you increase your selling price by $1, your sales volume will decrease by 500 units. This is basically a very important information, because by using this information, we usually identify that this question actually belongs to our pricing chapter, right? And then, for example, suppose variable cost or the marginal cost of the product is around $30, right? Not $30, let make it $28, right? So what we are going to do, we are going to find out a selling price that can maximize company's profit. And why we want to do this? We want to do this because we know, because see, actually I want to increase the selling price, because if we increase selling price, my profit per unit will increase, but that has an adverse impact or effect on my sales volume, right? So I need to know that what selling price company should charge, so that company can maximize the profit, right? So this is an option for company can set any other selling price if company may want, but at that selling price company will not be earning the maximum profit. That's basically the issue, right? So let's see what's in the question. See, first of all, you have to identify a selling price at which demand will be equals to 0, right? That means you have to calculate A first. And if you want to calculate A, you must know the other three factors, the other three variables from this equation, right? So P is equals to A minus BX. Now, what does this P minus A is equals A minus BX is representing? This is actually representing the normal demand function, because normal demand function is usually downward sloping, right? So this equation actually belongs to this particular line route. Now, P is equals to A minus BX, where so now for this equation, company is reasonably sure that if selling price is 50, then company can sell 10,000 units of the product, right? This is basically X. And what will be the value of B in this case? B will be change in selling price divided by change in sales volume. So if you change sales volume, selling price by $1, sales will decrease by 500, right? So this is the value of B, this is the value of X, and so we can find out the value of A, right? So let's divide 1 divided by 500 is actually equals to 0.002. So 50 is equals to A minus 0.002 times 10,000, right? So what will be the value of A then? A will be 0.002, 0.002 multiplied by 10,000 and plus 50, that will give you around 70, right? So if selling price at $70, your sales volume will be theoretically equals to 0. Why I'm continuously saying theoretically? Because practically you company will be selling some units, but that sales volume is completely ignorable. I mean, you can completely ignore that sales volume because that is very low in terms of quantity. I mean, that's ignorable part. Now, so we got the value of A, we got the value of B. So what we can do, we will move to the third step. We will move to the next step, which is plug in the value of A and B in the above equation. So now what we will do, we will write P is equals to 70 minus 0.002 of X. Now what does this equation is representing? This equation is actually the price equation for this particular question, right? If you have any other question, price function will be different for every scenario, for every question, right? So we are done with this price function. Now what we have to do, we have to convert this price function into marginal revenue, right? Now, why we will convert this into marginal revenue? Because we don't have to equate price with marginal cost. We have to equate marginal revenue with the marginal cost, right? So how can we equate, can we convert price into marginal revenue? It's simple. There one option is that uh, there is a formula that marginal revenue is equals to A minus 2BX. So you may follow this equation. Simple rule, right? No one is going to ask you what actually happened. But a few students ask actually that why we are multiplying A minus 2B, why marginal revenue is actually equals to A minus 2BX. What's the reason behind that? So reason is very simple. See, if you want, this is the price equation, right? P is equals to 70 minus 0.002 of X. This is the price equation, right? If you want to convert price into revenue, what you will do? You will multiply price with sales volume in order to get sales revenue, right? So what we will do, we will multiply this whole equation with X. X is what? X is the sales volume, right? So you'll multiply this whole equation with X in order to get in order to convert it into revenue. So P will be converted into R, which is revenue, 70 of X minus 0.002 of X square, right? Now, this is revenue. If you want to convert revenue into marginal revenue, what you have to do, you have to take the derivative, because derivative actually measures the rate of change, right? So, if you want to take the, if you want to take the marginal part, you have to take its derivative. If you take derivative of this whole equation, what it will be? Revenue will convert into marginal revenue. Derivative of 70x is going to 70, and derivative of 0.002x square will be 2 multiplied by 0.002 of x, 2 minus 1. Those who know derivative, they can do this. Those who are from commerce background, they don't know anything about derivative, so they may continue with this part, right? So what will be the marginal revenue in this case? Marginal revenue will be 70 minus 2 multiplied by 0.002. X2 minus 1 is equals to 1. So this will be equals to this. So this actually becomes the same formula. Marginal revenue is equals to A minus 2BX, right? So examiner will not ask you this. I mean, this is just an analysis. Examiner is not going to ask this. So what will be the marginal revenue in this case? Marginal revenue will be equals to A minus 2BX. So marginal revenue will be 70 minus 0.004 of X. So this is basically marginal revenue. And what is marginal cost? Marginal cost is the variable cost, which we have already identified as 28, right? It's simple. So marginal cost is 28. So marginal revenue is equals to marginal cost. So this will be 70 minus 0.004 of X is equals to 28. So this means what? You just need to solve this equation. I'm doing it directly at my calculator. So 70 minus 28 is equals to 42 divided by 0.004 is actually equals to 10,500, right? Okay, fine. So X is actually equals to 10,500. This X is actually representing what? This is basically the sales volume at which company can maximize its profit, right? This is the sales volume, and we have to calculate the selling price, right? So how can we calculate the selling price? See, this is the formula of calculating price for this particular question, right? So price function is equals to 70 minus 0.002 of x. Don't put this quantity in marginal revenue. We are not calculating marginal revenue. We are supposed to calculate selling price, right? So you just need to plug in this value here. So this value will get, so when you plug in this x 10,500 in here, that will give you a selling price at which company can maximize its profit. So P is equals to 0.002 times 10,500 and minus 70, that makes 49. So at a selling price of 49, company can maximize its profit. So if someone asks you that I don't want to have a selling, I don't want to fix a selling price of 49, I want to fix selling price of 45, then you may proceed. I mean, this is not a legal requirement, man. So you can proceed with 45, you can proceed with 40, you can proceed with 60. It's completely your company, your product. But what we are suggesting that look, if you keep your selling price 49, you can sell 10,500, and this particular situation, this particular combination will maximize company's profit, right? So this is a very simple explanation of the term marginal revenues equals to marginal cost, how you will apply that. Thank you for watching this video. Have a nice day. Allah Hafiz.